Welcome back, everyone. In this lecture, we're going to be talking about NumPy operations. We'll discuss various arithmetic operations as well as some universal array functions and summary statistics you can use with NumPy. These sort of operations will easily extend to pandas as well. Let's get started. All right, now I've already imported NumPy as NP. The next thing I'm going to do is set array equal to NP arrange 0 to 10, and let's check out this classic array. Now let's quickly talk about arithmetic between arrays as well as arithmetic between a scalar with an array. If I were to take this array and say plus 5, what's going to happen is NumPy will perform this operation on an element by element basis. So it will take every number in that array and simply add 5 to it. And the same goes for any major function. So for example, array minus 2, etc. It all happens on an element by element basis. Now, the same thing happens when we take an array and do an operation against another array. Keep in mind, these arrays have to be the same shape in order for this to work. So, if I were to take my original array and add it to itself, I've essentially doubled every number in the array. And keep in mind, what's going to happen is I can do this for any sort of operation. Multiplication, division, etc. So subtraction, everything goes to 0. Something I want to point out is NumPy is a little bit special in the way it deals with divisions by 0, or with something like a division error. So what actually happens is you get a warning instead of a full error. For example, if we take a look at my original array, I have 0 as one of the options. So if I were to say my array divided by itself, I'm going to end up getting, at the very first index location, 0 divided by 0. Technically, mathematically speaking, this doesn't really actually make sense. But if I run this, notice NumPy will still output a result. However, it will give you a warning that some sort of invalid value was encountered during division. So what it does here is it replaces 0 with, or 0 divided by 0 with this nan or not a number. What's also interesting is if I were to try to do 1 divided by 0 in normal Python, I will get a 0 division error, division by 0. However, if this occurs within NumPy, so if I do 1 divided by an array, essentially taking the reciprocal of every number in this array, at the very first element, I would get 1 divided by 0. So normal Python won't let you do that, but if you have NumPy, what's going to happen is it will also report back, again, a warning, divided by 0 encountered in true divide, but it has this sort of placeholder with divided by 0 by saying this infinity. So keep in mind, if you have 0 being divided by something, such as 0, we'll end up getting not a number. If you have some sort of element or scalar being divided by 0, then we'll have this placeholder of infinity there. The main thing to notice here is that NumPy won't give you back a full error. It will only give you back warnings, and it will still actually output a result. This could be dangerous because often we would expect our program to crash or have an error when NumPy will kind of keep chugging along, replacing this with either nan or infinities. It's just something to keep in mind. Now NumPy also comes with many universal array functions. So we saw the basic ones that are built into Python like arithmetic and division, but there's other things that we can easily call on every element in this array. For example, I could say np sqrt for the square root, and we can see here we've taken the square root of every number in that array. And I can do things also like trigonometric functions. So take the sine of every number in that array, or take the log of every number in that array. And same thing here, we start getting errors if we try to take the log of 0, since mathematically it doesn't really make sense. Again, we just get a warning, we don't actually get a full error. Okay, so something to keep in mind, there's a lot of universal array functions that are available to us in NumPy. And if you go to the lecture notebook for this particular lecture, we link you to this documentation page with, if you start scrolling down, it'll have a list at the bottom of all the different math operations, trigonometric functions, comparison functions, etc. that are available to you in NumPy as universal functions. So we can essentially just do np and then do some sort of call here. So that link is available to you. However, we won't really be using too many extravagant NumPy universal function calls. What we will be using a lot are summary statistics on arrays. We're often dealing with really large data sets, and we want to perform some summary stats in order to get an idea of just the general intuition behind the data set. So we can do this if I check out my original array. I can call things such as sum which we've seen before, that actually just sums up every element in this array. But there's other ones such as mean, which takes the average, or I can also call things like max. Now there's other things like the variance and standard deviation, which we'll discuss further, especially when dealing with real data sets. But keep in mind, those are already all built into Numpy, so we don't actually need to calculate those out ourselves. The main thing I want to point out here is that there's the component of axes logic. So right now we've been doing everything across this one-dimensional array, so it makes sense that if we sum things up or take the mean, it takes all the elements into account. But let's go ahead and create a two-dimensional array. So I can do this by saying something like np arrange, and then what I'm going to call here is, let's say, 0 through 25, and if I run that, I get these 25 elements, so I can reshape this to be 5 by 5, and then I get back this two-dimensional array. So let's go ahead and say array2d is equal to np_arrange, which means the shape of this two-dimensional array is 5 by 5. Now, I could call something like sum on this, and it will sum up all those numbers. But let's imagine I actually wanted to get the sum of maybe all the rows or all the columns. How do we actually do this? Well, you'll notice that sum actually takes in an axes parameter, which means you can actually specify whether you want to perform this operation across the rows or across the columns. Keyword being across. So what I'm going to do here is say array2d dot sum, and I'll say axis is equal to 0. And the result here is 50, 55, 60, 65, 70. So recall when I say array2d shape, the element at index 0 is the rows. So rows is represented by axis equal to 0, which means if I were to say dot sum at axis equal to 0, it means perform this operation across the rows, which gives us this result, which is technically the sum of the columns. So that can be a little confusing for beginners. The fact that by saying axis is equal to 0, it means perform the operation across the rows. Similarly, I can say array2d dot sum and set axes equal to 1, run that, and that'll perform the operation across the index 1 of shape, which is the columns, so it performs this operation across the columns. So keep that in mind. Axis equal to 0 says perform this operation across the rows. Axis equal to 1 says perform this operation across the columns. That can often be confusing for beginners because they kind of expect the results here to be switched. But the key word to remember is the operation across. Okay, so that's it for this lecture. We'll be using these sort of method calls and arithmetic calls later on in the course. I'll see you at the next lecture.